Hello viewers, welcome to this video. In this video we will be looking at the 2021 GCE Science Paper 1, question B3. Question B3 reads, Figure B 3.1 is a diagram showing a uniform meter rule freely pivoted at its center. A Newton meter is hung 20 centimeters from the pivot while a 4.0 Newton weight is suspended 40 centimeters from the pivot. Figure B 3.1 is a diagram showing a uniform meter rule freely pivoted at its center. A Newton meter is hung 20 centimeters from the pivot while a 4.0 Newton weight is suspended 40 centimeters from the pivot. So we have our figure there. So we have our pivot. So we have our pivot here. So the pivot is there. Okay, so the pivot is here. So we can try and illustrate it like that. So the pivot is there. Okay, we've got a Newton meter there, and we've got a 4 Newton weight there. So the weight is actually pulling the whole thing downwards, while the Newton meter is pulling the whole thing upwards. Okay, so we've got two forces, the 4 Newton force and another force F, which is exerted by the Newton meter upwards. And the force F is 20 centimeters from the pivot, while the 4 Newton force is 40 centimeters from the pivot. All right, now because it is pivoted at the center of the rule, meaning that the weight of the rule plays no part in this whole arrangement. The weight of the rule is ruled out as any potential force that acts on the rule. All right, so now the meter rule is in equilibrium. What does the word equilibrium mean? Equilibrium means that the meter rule is balanced. So the meter rule is balanced. So let's start with A. A, state the principle of moments for a body in equilibrium. State the principle of moments for a body in equilibrium. So what the principle of moments states is that for a body in equilibrium, the sum of clockwise moments is equal to the sum of anticlockwise moments. So for a body in equilibrium, the sum of clockwise moments is equal to the sum of anticlockwise moments. So since we've already been told that the body is in equilibrium, so we state the principle of moments for a body in equilibrium. So we'll state that the sum, okay, allow me just to start by stating that for a body in equilibrium, I'm not so comfortable just starting at the sum of clockwise moments is equal to the sum of anticlockwise, just because they've mentioned it there. I'm just not used, so let's just start it from the beginning. So for a body in equilibrium, which they've told us, the sum of clockwise moments is equal to the sum of anti-clockwise moments. So like that. Yeah, so for a body in equilibrium, the sum of clockwise moments is equal to the sum of anticlockwise moments. So it's always the sum of. So it is not just for a body in equilibrium, clockwise moments are equal to anticlockwise. No, it's the sum of these moments that are equal. All right, B, calculate the reading on the Newton meter. Calculate the reading on the Newton meter. Now, okay, so what they are basically telling us is that because I've already put a force F, which the Newton meter exerts, this is the force with which it will read there. So we are just asked to calculate the force with which the Newton meter exerts on this. And we can now say that, okay, this is our F. Let's say, since it is the closest to the pivot, let the force exerted by the Newton meter be as F1, and the distance from the pivot to F1 be equal to D1. Okay? So, how far is F1 from the pivot? The distance will be D1. And the weight of this object, let this be F2, which is force, the second force, and the distance for this force, D2. So, because we only have two moments, which is clockwise being this one exerted by the Newton meter, because clockwise it should cause the object to turn in the same direction as the hands in a clock, while anti-clockwise, which is the 4 Newton force, it causes the meter rule to turn in the opposite direction to the hands in a clock. So we have clockwise moment by the Newton meter, anti-clockwise moment by the 4 Newton force. So we only have two moments, and because all these distances are in centimeters, there is no need to change. The units will just cancel out and we will remain with what we are remaining with. So we have F1 times D1. D1 is 20 centimeters. So what we are going to say is, we're going to say that F1 D1 is equal to F2 D2. Okay, so F1 is just F1, okay, which is the force exerted by the Newton meter. So we are going to have F1 multiplied by 20 centimeters is equal to 4 newtons multiplied by 40 centimeters. So we are going to divide both sides by 20 centimeters. We'll divide even that side by 20 centimeters. So the 20 centimeters this side goes, and we remain with F1. Then here, the centimeters, now you can see the centimeter cancel with the centimeter on top, leaving the only units to be newtons. So what I'm going to do now is I'll say 20 into 20 is 1, 20 into 40 is 2. All right, so I'll have 4 newtons multiplied by 2. 4 newtons multiplied by 2. What is 4 times 2? So F1 is equal to 4 multiplied by 2, which is 8 newtons. So the reading is 8 newtons. So I'm going to write 8 newtons there. So that is how we find the reading there. Okay, that is how we find the reading. So we move to C. So C, state with a reason whether the Newton meter reading would increase or decrease when the 4 Newton weight is moved to a distance of 30 centimeter away from the pivot, 30 centimeters. So in the beginning, it is 40 centimeters. Now it is moved closer. Okay? Now, what we should take note about moments is this. Okay? The shorter the distance from the pivot, the smaller the moment. Okay? The shorter the distance, the smaller the moment. The bigger the distance, the bigger the moment. So, in moving the 4 Newton force to a distance closer to the pivot, we reduce the moment. Hence, even the balancing moment, the balancing force on the other side should equally reduce. So the Newton meter reading there will reduce because the counter moment has reduced. So it will reduce because the anticlockwise moment has reduced. Has reduced, okay, because the anticlockwise moment has reduced and its distance has remained the same. So that is what is there. So it will reduce because the anticlockwise moment has done what? Has reduced. Thank you very much, viewers, for watching this video. If you like it, give it a thumbs up. If you're new to the channel, don't forget to hit the notification button so that you are notified. And other than that, don't forget, the greatest thing is don't forget to subscribe. Subscribe, hit the notification button, and you're good to go. And continue enjoying the material posted on this channel. Thank you very much.